Today we will be doing the AP Calculus AB FRQ number 6 from 2018. And this one gives you a differential equation that you have to work with a given slope field of that. And this one is not that bad, so it shouldn't take too long. So I have some things laid out right here of already what it'll be, so I'm just going to click through some of these. Part A just states that you need to sketch the solution for the curve at 0, 2 and 1, 0. So those are those two things right there. 1 clearly has 0 slope, and I plugged in the points, and you can see that that is the case. And then right next to it, below it, is just a curve up that you can follow pretty easily. So that is all part A has for you. Then for part B, we'll start with the clean slate here. It says, let y equals f of x be the particular solution to the given differential equation with the initial condition f of 1 equals 0. So you just have to write the equation for the tangent line at that. So for this part, the first thing that you know is that dy over dx at 1, 0 is 4/3. And that's pretty easy plugging it in right there, as you can see. And then going right along, you just can use point slope. I was surprised that I remembered that formula after not using it for so long. And then it's just plugging it in for the rest of it. And then you have to finally approximate what f of 0.7 is. And you just plug the points into what you got before in point slope. And then there it is. So with this, you can already see that because the slope is 4/3, it's pretty much the exact same thing. You know that you just move back across the x-axis negative 8.3, so it's just negative 0.4 down. So it's not hard to follow. Okay, and part C finally. Here we have to find the solution to y equals f of x for the differential equation with our initial condition f of 1 equals 0. So we will start with our original differential equation that we are given right up here. So the first thing that I did here was I multiplied everything by dx over y minus 2 squared. It is kind of hard to show all this on the computer, but I did my best to format it readably. And then after that, because things are pretty well set out for you to take the integral of both sides, because this is a differential equation, so we just take the antiderivative of both sides, and then it is pretty simple, no u substitution or anything required. We just see that you can just reformat this as negative 8 y minus 8 2 to the negative 8 first, instead of having it be like it was before. And then we have 1/6 x squared and plus c, because that is the side with our x on it. It is the independent variable, so it's just better to have it on that side. It doesn't really matter. Then next, we just see that at f of 1 equals 0, the 0.10, we can just plug those into what we just got in order to get our c. So we have 1/2 equals 1/6 plus c, and it's pretty easy to get. C equals 130. And then after that, we just add our C to what we had a moment ago, and then we can simplify that down. I did a lot to get around this. I spend too much time simplifying, but we get a nice little function here for the end of part C, which is f of x equals negative 6 over x squared plus 2 plus 2. So that is all for this FRQ. Thank you for listening. Have a great night.